In this example, we are going to use dynamic of uniform circular motion to solve the problem of pendulum. We have conical pendulum. We have a mass M. This mass is attached to the string, and the string is connected to the ceiling and is making a circular uniform motion on this horizontal plane. So the question is to find the speed of this ball and also the period of the ball. The period means the time it takes to make a complete revolution. We have the radius of this circle, r, which is this one, is the same thing, is given by this r. If I use this angle alpha, the alpha is the angle between the string and this vertical line. So the radius, if I take this triangle, is 90 degrees here. So this radius r is the length of the string sine of alpha. So the question is, we need to find the speed of this mass m and also the time it takes to make one complete circle. We'll call it a period. So the first thing we need to do is get the free body diagram and then use Newton's second law to solve the problem of motion. So for the free body diagram, we circle the object and we see what pulls and what push on the object. The object is under force of gravitation, we call it mg. Because the object has mass, by definition it will have weight, which is mg, and also is attached to the string, and this string will have a tension T. So this is the two forces we have. Now we need the reference. How we choose the reference? First, we need to identify the direction of acceleration. Then, and we take our x-axis as the direction of acceleration. The object is making circle on this horizontal area. So the acceleration, it will be centripetal, means it will be toward the center. The acceleration will be, if the object is here, the acceleration will be centripetal. If the object is at this point, the acceleration will be toward the center. So now we identified the direction of acceleration. We are going to make our reference x and y axis. This is what will be our x-axis. Let me clean this now. So we know the direction of acceleration is toward the center. So our x-axis, this is x-axis. And y-axis, by definition, is perpendicular to x-axis. In this case, you'll be just passing by, this is y-axis, and the negative y will be in the same direction as mg. Now, in this case, we use Newton's law. You say the sum of forces is the mass times acceleration. In this case, it's centripetal because it will be toward the center. So we have the tension plus mg equals to the mass times centripetal acceleration. We need to drop the tension on x and y axis. So in this case, we have to go to the algebraic values for f, net f, which is sigma f on x and sigma f on y axis. Because this net force will have coordinate on x and coordinate on y axis. The coordinate of this net force on x axis, it will be the tension. Remember, this is alpha. If this is alpha, this angle also will be alpha. If this angle is alpha, if I drop T perpendicularly on this axis x, this also will be alpha. Because we have these lines are parallel and these angles are alternate, so this will be alpha. We have T sine alpha. On x-axis, the tension on x-axis will be just Tx, and this Tx will be just T sine of alpha. Let's clean this and clarify this first. So for We said our x-axis is this line. So if I drop this tension T on x, I have this is 90 degrees, and this angle we said is alpha. So what will be this T? This is T, and the coordinate of T on x-axis. We need to look for the opposite side of alpha. We said last time, if I'm looking for the front side of the angle, I will use the sine of the angle times the hypotenuse. It will be the front side of the angle. That means this Tx, it will be the hypotenuse times sine of alpha. So we said Tx, let me put it here. Tx, it will be T sine of alpha. And also the coordinate of tension on y-axis. Remember, this was the y-axis. Is the vertical. This is alpha, we said. T cosine Ty, it will be just T cosine alpha. T cosine of alpha. Now I go for Newton's second law. We said the sum of forces equals to the mass times centripetal acceleration. This tension will have to coordinate. On x coordinate, it will be Tx, and we say Tx is T sine alpha. And mg on x, it doesn't exist because mg on vertical axis, which is y-axis, we said. So it doesn't exist. And this only force we have is T sine of alpha equals the mass times centripetal acceleration. Now on vertical axis, what do we have? We have Ty, which is the projection of T on y-axis. We call it Ty. And we say Ty is just T cosine of alpha. And mg is downward, it will be minus mg. And this is equals 0. Because remember, the acceleration is centripetal, is in x-axis. There is no vertical acceleration. This is why the sigma of Fy equals to 0. Now I need to find this tension, what it is. From the vertical axis, we have T cosine of alpha minus mg equals to 0. That means T will be just mg divided by cosine of alpha. Now I go to this equation here. Instead of T, I put just mg cosine of alpha. And what we have? Let me put this T. We say T sine of alpha is the mass times centripetal acceleration. This centripetal acceleration, we said by definition, is the square of the speed over r. So it will be the mass times the square of the speed over radius of the circle. Radius of the circle is this one or this one, same thing. So what do we have? This tension is the mg over cosine alpha. That means I will just replace tension with mg over cosine of alpha times this sine of alpha equals to mv squared over r. So the mass, we can cancel the mass. We have it here. We have it here. We can, and also we know cosine of alpha over cosine of alpha is just tangent alpha. And then we multiply by r each side. We will have the speed squared is rg tangent alpha. So v will be the square root of rg tangent of alpha. Now let's replace r. We said r is length of the string times sine of alpha. Now if I want to replace r here also, it will be just the square root of length times sine of alpha times g times also tangent of alpha. We can replace tangent of alpha with sine of alpha over cosine of alpha again if we want to. Then sine of alpha times sine of alpha will be sine of alpha squared. the square root will be just sine of alpha square root of the length of the wire times acceleration of gravity divided by cosine of alpha. This is what will be the speed. To find the period, we know by definition the speed is 2 pi r over t. So we can find the t, which is the period, which is the time it takes to the object to make one complete circle or one revolution. It will be just 2 pi r over the speed is given by 2 pi r over the speed. We find the speed is sine of alpha times the square root of the length of the wire times g divided by cosine of alpha. R is length of the wire times sine of alpha. We can replace here. The period t will be 2 pi times L sine of alpha divided by sine of alpha times square root of Lg divided by cosine of alpha. Now the sine of alpha vanishes. We'll have 2 pi L over square root of Lg over cosine of alpha. So we have L here, we have L here. We need to put everything. It will be 2 pi square root of L squared, because we put this L inside square root, it will be L squared, divided by Lg over cosine of alpha. One L vanishes, it will be L cosine of alpha over G. Okay, so this is what will be the period, which is the time it takes to the object to make one complete circle.